Okay, now let's look at the 0AM transmission from Volkswagen. The 0AM transmission is a DCT type transmission. It's a direct shift gearbox, and it is a replacement, a direct replacement for the 02E transmission, which is the earlier 6-speed model. This happens to be a 7-speed application with a dual disc dry clutch. So we have another dual disc dry clutch DCT type application. And of course, we're not going to be getting like that silky smooth takeoff and launching. So again, this is going to be one of the main complaints with this unit, or one of the main concerns, if anything. But then again, it is a matter of making sure that the individual who owns the vehicle is familiar with the application of this vehicle, being a manual shifted transmission that is controlled by a computer. So again, this is going to be just like any other standard transmission in that respect. Now basically, we are going to have inside this unit pretty much two separate gear trains, which is the whole purpose behind a dual clutch application, where we'll have an odd gear train and an even gear train. So on the odd gear train, we'll have 1, 3, 5, and 7 gears, and on the even, we'll have 2, 4, 6, as well as reverse. So the power flow is going to be presented a little bit later on, but pretty much this is going to be the mainstay that Volkswagen has gone to in their smaller application engines. A lot of the diesel applications will have this transmission, as well as hybrid applications. So as far as stateside, there's fewer vehicles that we're seeing now with this transmission. However, worldwide, since most of the rest of the world uses diesel type applications more than petrol or gas applications, they're seeing these in mass. So here's the information on this transmission and details we need to know. First of all, this transmission is found in quite a few of the Volkswagen applications, as well as Skoda, Seat, Audi, and pretty much those are the main makes and models that are going to be using this design. Again, this is a direct replacement for the 02E, and the 02E was a wet clutch design, dual clutch. So with this in mind, it is a very notably different transmission. Another designation for this is the DQ200. So if we're looking at literature, we might see it referred to as the DQ200. Now, looking a little bit deeper into this unit as far as identification, we do have a tag that's going to be etched into the case as shown in 2 locations. So as far as identifying what application we have, we can utilize that information and the chart that's presented here to determine the origins of a transmission, especially if you're acquiring a core unit. And pretty much you'll be able to match things up that way. Now, breaking down the actual tag designation of this unit, basically again, the D is going to stand for a dual clutch type unit. Then the Q means transverse mounted, so front wheel drive application. And then the number 200, that's going to be a relative number that's going to refer to the maximum input torque that can be applied to this transmission. And then you'll have a dash, and it'll be 7F. 7 refers to the number of gears, forward gears, that this transmission is going to have. And then the F is going to refer to the front wheel drive. Now, as far as fluid capacities on this unit, you want to be aware that there is not a dipstick in this transmission. As far as checking the level of this fluid, unfortunately you can't do that. You can drain the fluid out, so basically anytime we're going to be servicing this unit, or if there's a question as far as the level of oil that's in this unit, and there's going to be two sumps. We're going to give you details on that as we move along. You're going to have to completely drain the sump in question, and you're going to have to fill the sump by volume. And basically we have two separate oil fills, and again, with this type of transmission, it's very unique as far as the way Volkswagen engineered this and designed it. It's unique as far as the fact that we have our gear oil that's separate, so it's going to be responsible for lubricating the gear train, much like a manual transmission. Basically, just have its own area where it's just going to keep all the gear train and bearings lubricated. And then we're going to have oil in the valve body control area separate. So again, two separate sumps. Now, first of all, when we're looking at the valve train area, in other words, the area where we're going to have our solenoids, all our hydraulic actuators, we have a fluid capacity of 1 liter of special oil that's going to be in that area, and it's going to be the area, well, the control mechanism for this transmission is referred to as a mechatronic. Now, mechatronic is an assembly with the solenoids and all the actuators, as well as a fluid pump that's going to be used to generate pressure for operating the shift forks, as well as the different solenoid actuators to move the shift rails. So again, this unit is going to have a capacity of 1 liter. You cannot really check the level, so if there's a leak, you do want to drain the remaining fluid and add the capacity that's specified here. And also, there is an updated fluid. Again, this is going to be very much like a power steering type grade fluid. So we're just pressurizing this fluid, and we're not lubricating or anything with it. So there's not a lot of requirements for high detergents to carry debris away or anything. We shouldn't have debris in this area of the unit and the valve body. Now, as far as the gear train is concerned, it's going to have its own drain as well as fill. And here we give you the specifications as far as where to fill and where to drain. Anytime you want to add fluid to one of these, either one of the sumps, you can add through the vent area. So we show you in the diagram where you can fill this unit. And again, it's going to be filled by capacity only. So if this unit's coming in leaking, we're going to want to go ahead and just drain all the oil out of it. And then we're going to want to refill this based on the recommended capacity of 1.7 liters. So again, we give you the specifications for the fluid that's recommended. Now, as far as the gear train, the power flow, basically, again, we have two clutches with dual clutch. Both of them are dry, so there's no fluid that's going to be involved here as far as the clutch material, getting into the fluid per se. And that's what makes this unit so predictable with the as far as the fluid, being able to be reliable, if you will. We're not trying to share that fluid with trying to cool the clutch down or anything like that. So it's just regular air dry, just like a typical manual transmission. Now, as far as our inputs are concerned, we're going to have two input shafts. Again, input shaft number 1 is going to be our odd, and then input shaft number 2 is going to be our even, shown in the diagram here. And we are going to have 3 output shafts. So again, it's going to be a matter of the power flow gear selection, which shaft is going to be active based on the gear selected. And anytime that a gear is selected, the next gear is going to be pre-selected on the opposing shaft that is not activated by the clutch. Now, with that in mind, taking a closer look, we see that our inner shaft is going to be called our K1, or our odd gear shaft, and our outer input shaft is going to be called our K2, or our even gear shaft, which is also the even, as I stated before, the even gear shaft is going to have the reverse gear mechanism on it as well. And again, we have 3 different output shafts as shown in the diagram. So pretty much this is a very compact unit. And everything in here is, interconnected accordingly based on the clutch actuation. Now, taking a closer look at the mechanisms, the shafts as they're arranged inside the unit. First, let's look at the output shafts. We have output shaft number 1, which is basically going to be our drives for our odd gears. So again, with this design, there's going to be a lot of interchanging here, and again, with the gears, gear selecting. We're going to be driving this for our odd gears primarily. Here's our output shaft number 2 with the gear selections that are available as well. And then we have output gear shaft number 3, which is going to be primarily used for our reverse engagement only. So, and it's also going to house the park mechanism. So basically when we're shifting into park, the slider is going to engage that shaft to actually allow for us to mechanically hold through the transmission. Now, as far as the synchronizers are concerned, we have synchronizers that are very similar that are found in typical manually operated transmissions. We have the 3-surface, 2-surface, as well as the single-surface brass molybdenum type synchronizers. Basically, they use the additional surfaces in the lower gears, which is going to be a higher torque shift transfer. So actually stopping that gear smoothly is going to require more surface area, and that's why they have the 3-piece and the 2-piece design when there is a wider ratio separation. And again, that's going to be found in the lower gears. And the upper gears, of course, there's less of a ratio separation, so they don't require as much braking force for the synchronizer and for the sleeve to engage. Here we're showing you information on removing this unit. Now, of course, when we need to change the clutch out on this, which is going to be the primary reason why these units are coming into the shop, it's time to change the clutch, then we have to remove the unit in order to do so. Now, before you remove this unit, you are going to need to acquire some breather plugs. There's some caps that are usually going to be furnished with a clutch kit that you purchase. So Luke is the OEM manufacturer. There may be other manufacturers out there, but the Luke, if you happen to use the Luke kit, then it will come with these breather cap plugs. This is going to be necessary to use so that we don't lose fluid when we take the transmission out and we're rolling it around on the bench, doing what we need to do to change the clutch out, as we'll show you a little bit further in this presentation. Now, as far as, once we get the plugs installed, then we're able to remove the transmission so we don't lose fluid. Now, if you plan on servicing the fluid as well, then it is recommended to drain the main sump, which is going to be the where we showed you earlier with the 1.7 liters from the gear train portion. And accessing the drain area for the mechatronic, there's going to be an Allen head bolt right at the bottom of the mechatronic assembly that you can remove, and it'll drain most of the fluid out. It's not designed to be an official drain. However, you can utilize it as a drain so that you don't spill fluid all over and when you remove the transmission. Now, as far as servicing the unit as a whole, there are some common failures that do occur with this unit. Of course, this is no different than any other direct shift gearbox type transmission. We're going to have some concerns with bearings. The bearings themselves are going to be taking a lot of load, a lot of force. You got a lot of pushing force against the shafts, and the bearings are the opposing force to keep those shafts parallel. So that's where you get your concerns with bearing failure, bearing noise, bearing wear. These bearings are available, but we will have to take the unit apart in order to service them. Now, in order to take the unit apart, the snap ring that's shown here is going to need to be removed. So that's going to be first and foremost. We show you that that snap ring is located on that shaft, and basically then we're going to have to pull the case halves apart. Now again, this is very much like a manual transmission, so again you might have to invent an apparatus to actually pull these case halves apart. So it's not going to be anything that you can just get a few pry bars on and pull it out like that. So you're going to actually need pullers, and there are factory tools that are available for this process. Now once you get the case half off, then it's going to be pretty much self-explanatory at this point. You don't have to remove the shift rails or anything like that, shift forks. The shafts will be able to be maneuvered out, and the bearings can be serviced at that point, and then you can return it back into service accordingly. Now as far as looking at the clutch assembly, this dual disc clutch assembly is available. Again, Luke, they are supplying the aftermarket as well as the OEM, and they have something called a rep set. And pretty much there's going to be two versions of this, two general versions of this. We have an early version and a late version. The cutoff point is going to be about July 2011. So depending on the vehicle, year, make, and model, you do want to verify that your clutch, what version that you have to order for your application. So you want to have your VIN number available to make sure that you are getting the right application, especially if you're falling around that range of July 2011 and close to it. So there are some differences. They're not created equal. Now with that in mind, we also have a few parts that are going to be need to be inspected as we take this apart and we're changing the clutch or servicing the clutch assembly. We're also going to have to take a close look at the flywheel. It's going to be a dual mass flywheel. Now, as far as the way this assembly is put together, we have the dual disc assembly itself that's going to actually spline into the serrations that you see represented in that flywheel area. So again, it's going to be a matter of this assembly just mating up into that junction. So the dual clutch assembly is going to just be like cogged teeth into that dual mass flywheel. So again, it's a very simple, mechanical connection, but basically there's some adjustment that has to be performed to make sure that the clutch side of things is set up properly so that the actual throw of the clutch disc is going to be predictable or within the range that the computer can actually adjust to. So that's going to be something, again, where we have the shims and everything that are going to be able to get us in the range that we need to adjust this assembly accordingly. Now, taking a closer look at the dual mass flywheel, we see these teeth and these lugs, and then compared to the lugs that are on the actual dual clutch assembly, and that's where our junction is going to mate up with the engine. So again, that's a very critical junction, and it's going to be like the dual clutch assembly is going to actually tang into like a dampener assembly in the dual mass flywheel. And that's what we show you with the ID lugs there. There's going to be a spring, dual mass spring assembly in there that's going to be designed to actually, give us our vibration dampening capability, which is necessary with any type of flywheel or flex plate type situation in a clutch. A lot of times you'll see the springs in the clutch side of things. In this case, it's all in the flex plate side of things, or the flywheel side of things, the dual mass flywheel. So we're going to tang in there. The OD lugs are going to tang into the inner diameter lugs, and pretty much that's how our mating surface is going to be. We don't have to bolt anything together. It's just going to rest in there based on the clearances that are set up from the clutch side, and hopefully as long as the engine end play, the crankshaft end play is within parameters, we should have a very good junction there as far as a meeting point for those two lugs. Now, taking a look at the clutch mechanism itself. Now, with the clutch kit, most of the clutch kits are going to, quality clutch kit is going to have all of these components available for replacement. We have the shift forks, we have two shift forks, we've got throwout bearings, basically everything like a manual transmission, if you will, a typical manual transmission except double. We're going to have a pilot bearing. Basically, all of these components need to be changed and serviced at the time that we change the clutch out. Okay, don't shortcut it, because basically anything that you shortcut might be your weak link in the whole equation of things. So again, a quality kit is going to include all of these. Again, Lucas, the OEM manufacturer, so yes, they do have all of these components in their rep kit, which is going to allow you to adjust as well as install this correctly. Now, looking at the actual clutch mechanism, we have the K1, K2 clutch. Now, the K1, K2 clutch are operated on the same plane, basically. So, since they're coplanar, we have one that's going to be like a push type mechanism, and the other is going to be like a pull type mechanism, as shown in the diagram here, where we show the K1 clutch is going to be pushed to actually apply that clutch, but we're going to be, the plate is actually pulling in to put pressure on that clutch. So as we push the throwout bearing, the mechanism is creating a pivot that's going to pull the plate, the K1 clutch plate, in and allow the clutch to apply that way. With the K2, we're pretty much pushing linear, and the clutch is going to push on in the same direction for the K2 clutch. Now, as far as the transmission clutch operation is concerned, there can be concerns when we have to service different components on a transmission, specifically the mechatronic assembly. Now, if there is an issue with the mechatronic assembly and it needs to be serviced, you want to be aware that by changing the mechatronic assembly, we could actually have a neutraling situation after we change it, especially if it's a higher mileage vehicle. The typical life expectancy of the clutch is going to be about 60 to 80,000 miles, or, again, it all depends on the type of driving that's done. And as a matter of fact, the more stop and go driving that's done, which is, going to be the highest wear type of situation, then the more that clutch is going to wear. Basically, it's like a typical manual transmission. So again, you want to take into consideration the mileage, that the overall mileage that the vehicle has on it. If you do need to, if you determine that you need to replace the mechatronic assembly, it might be a time where you have to actually call the clutch, even though the driving conditions, don't show you that there is a problem with the clutch. The mechatronic might not be able to adjust for that wear, that normal wear that might be occurring, especially if that clutch is going towards the end of its life cycle. So again, something to be aware of with one of these units coming into the shop on the diagnostic side that you don't want to get caught on the short end of. Now, closer look at the mechatronic assembly. Again, the mechatronic assembly is going to be on the side of the transmission. and it has its own reservoir, own oil. It houses all the solenoids that's going to control all the actuators, and it's going to have an accumulator as well. We're going to talk about all the individual components. First of all, let's take a look at the clutch solenoids. Now, the clutch control solenoids indicated here, these are going to actually control the actual clutch rods that are going to turn the clutches on and off. So K1, K2, basically we have hydraulic oil that's going to actually push those rods in and basically allow the clutches to operate as designed. So we give you the designation for these solenoids because when you use a scan tool and pulling codes, and if you have issues or concerns, it will give you a letter and a number type component identification. That's very important to realize. So with that in mind, we give you gearbox 1, gearbox 2, the K1, K2 clutch solenoid controls as N435 and N439 respectively. So again, if you get a code with these numbers in them, then you're going to be going to the mechatronic assembly to the solenoids assigned inside as shown. Now, looking at the actual mechanisms themselves, again, this is a very direct type of unit. There's nothing fancy about it. We've got shift forks and we've got hydraulic pistons that are going to be controlling those shift forks. So as the solenoid directs oil to these hydraulic pistons, we're able to operate the clutch as designed. So again, we are going to pulse width modulate these solenoids to control the apply rate as well as the release rate. So again, this is going to be all selected by the mechatronic, which is going to be the computer that's going to control that hydraulic piston and that hydraulic solenoid action. Here we show the actuators themselves. Again, these actuators are going to actually contact the shift forks at a point where they're going to, right at the pivot point, where they can actually operate those forks and allow that clutch, whatever clutch they're assigned to operate as commanded. Now also, we're going to have some kind of a feedback mechanism. We have clutch travel sensors, and we give you the sensor ID numbers as well. So if there's any issues with their code set, it'll be G617, G618 for each one of those sensors. Basically, it's going to give feedback as far as the actual movement of the K1 and K2 clutch actuators. And the sensors themselves, they happen to be like a feedback coil type system where we actually have a permanent magnet in the actual shift actuator rod that's going to actually pass relative to a iron core type circuit that's going to pretty much interrupt the current of that iron core circuit, and it's going to change the voltage relative to the position of the magnet. So pretty much we're looking at two magnetic fields fighting, and then the voltage, basically the voltage difference between each end, is going to be relative to the position of that shift rod, or actually relative to where that magnet is. So if there's any issues with that magnet, if the magnet comes loose, if the magnet gets smacked during installation and breaks off, we might not have feedback, or we might have a feedback problem. So it's very important to realize, and that's why we show you this circuit the way that it's designed, if there are problems with that. So we do have to handle the actuators with care, seeing that there is basically it's just a typical magnet. So if you drop it, it will shatter. If you drop that rod in handling the mechatronic components, you can damage this magnet, and it will cause problems with our feedback coming back from our clutch travel sensors. We have clutch protection as well. This is going to be something that is a little bit hard to understand, but basically the computer, the mechatronic assembly, monitors the amount of slippage that takes place in the clutches, and it assigns a temperature relative to the amount of slippage that's allowed, because of course during the transfer, of start and stop and in between shifts, we're going to have a certain amount of heat that's going to build up just relative to the clutch releasing and applying at any given time. And basically it's a calculated value that's stored in the mechatronic as the vehicle is operating. And of course it's going to be a varying number just based on how long the clutch is on, how long the clutch is slipping, how fast the RPM differential is when the slippage takes place. All of those things go into the calculation of that number. Now with that in mind, the TCM is set to respond at certain temperatures. Specifically, we're looking at about from 680 to 716 degrees. We're going to actually go into what they call a failure management mode, and we're going to kind of warn the driver that, okay, we got a problem here. We're building up too much heat. So it's actually going to cause the clutch to shudder. So it's going to actually pulse so that we can, get the driver's attention, and it's going to say, so hopefully the driver will slow down or at least stay in a gear or drive steady. Now, if the driver still continues to drive, and usually it's going to be an aggressive situation where we're shifting between a lot of gears or maybe a lot of start-stop, if it goes above 716 degrees or 380 degrees centigrade, then it's going to actually go to a neutral condition. So it's going to command both clutches off. K1 and K2 clutches are going to be commanded off. You have to go off to the side of the road and basically wait until the computer allows you to engage again, until it calculates that the temperature drops down to about 644 degrees Fahrenheit or 340 degrees centigrade. Then it will allow for normal operation after that. Now basically, if our battery voltage or our vehicle voltage drops below critical level as well, we're going to have some issues with clutch operation. So at about 10.8 volts, if we drop below that level, then we're going to lose operation of our clutch. So again, that's going to be a neutralizing situation as well. So that would be voltage going to the mechatronic assembly. So if everything else is working fine and our voltage to the mechatronic assembly drops below our critical voltage, then we are going to go to a neutral situation. Now, looking at the mechatronic assembly itself in a little bit more detail, basically it is the transmission control module. So seeing that it is the transmission control module, it's going to have inputs as well as outputs. So inputs are going to be required so that the transmission can be controlled accordingly. Of course, the outputs are going to actually do the work that the TCM sees that is necessary to get the vehicle moving according to the way that the driver commands. So with that in mind, we're looking at everything that is entailed in the mechatronic assembly. Again, it's mechatronic assembly. Basically, the TCM itself is going to be in that assembly in the transmission that's bolted onto the side of the transmission. So all of the actuators, all of the sensors, anything that has to do with the direct operation of the transmission is going to be contained or attached to that mechatronic assembly, as shown as far as the inputs and the outputs that are with that unit. Now, here's a closer look at that mechatronic assembly. Now, before I go any further as far as introducing the various parts inside the mechatronic assembly, it's fair to give warning that when you get one of these mechatronic assemblies into your shop, there is going to be a warning sign that's on the outside of the case of this mechatronic assembly. You'll see the cover. It'll say warning, do not handle, or whatever it says on the outside. And that's for a reason. Basically, there is the potential of having extremely high pressure inside of this unit, specifically at the accumulator. If you look at number 6, that's the area where the accumulator goes. And a lot of times we'll discuss some concerns that happen in that area. But there can be upwards of 1,000 pounds of pressure, 1,000 psi, that's 70 bar, at this location, even with the engine off, even with the mechatronic on the bench. So with that in mind, you want to handle this with care. As a matter of fact, if this transmission comes in with a no-move situation or barely moves, and you're able to diagnose and see that the pump is running continuously, something of that nature, this is something where we want to be able to make this assembly safe. And we're going to discuss that part a little bit later, because the accumulator is going to be the main focus area, because that can house a lot of pressure. It can store a lot of pressure, even with the mechatronic assembly on the bench. And it can actually release, and it can cause some catastrophic damage. So again, we want to make sure that you are safe with this unit. But again, we'll cover the details on how to handle that in case, just to make sure that you do stay safe. We don't want anybody getting hurt with components like that. Now, basically, as far as everything that's listed here, we have solenoid groups that are controlling each side of the unit, if you will, the odd gears and even gears. And pretty much, again, it's a very basic and straightforward setup here. And the nerve center of this all centers around our ability to utilize a very small amount of oil to run all of these solenoids and move all these shift forks and actuate the clutches with a self-contained sump, which is subject to very little, if any, contamination at all. So as far as sticking valves and anything like that, it's almost unheard of with this application. Most of the failures are relative to solenoid failures and other components failing inside. So just to keep that in mind as far as the mechatronic assembly is concerned. Now, taking a closer look at this, we show you all of the components here as far as the shift actuators, sensors, and everything in their location. And pretty much, again, output speed is going to be calculated via the wheel speed sensor. So just to keep that in mind, we're not going to be looking at an output speed sensor for this transmission. Now, taking a closer look at the speed sensors, we give you the identification, the letter and number identification, should we have any concerns with the sensor and the locations. Basically, we have an input speed sensor location as well that's going to be in the bell housing area as indicated in the picture. And pretty much we give you the duties of the speed sensors as well. They're all going to be Hall effect design. So we're going to be feeding a voltage, and we're going to be generating a square wave with these speed sensors. The transmission fluid temperature sensor is located in the actual mechatronic assembly. The computer area is shown. Basically, it is going to be a direct feedback to allow the computer to adjust the clutch timing, the clutch shift timing, as well as take any evasive actions to make sure that the temperature doesn't rise too high in the mechatronic assembly. So we do have a failure management, if you will, a failure management strategy that's going to be invoked in this module. So at about 282 degrees Fahrenheit, 139 degrees centigrade, basically we're going to start to reduce the engine torque so that we don't burn the clutch up. And then if we go above, if we go like 298 degrees or higher, then basically we're going to pretty much take most of the throttle away from you. It's going to be like a creep mode. And then it's going to be that way until our temperature drops down to about 275 degrees Fahrenheit or less. So again, if we end up with a situation of, maybe a temperature sensor that's not reading correctly, and now this is going to be the mechatronic assembly itself. So if you want to monitor that temperature, you can utilize a infrared temperature gun and point it at the side cover where the mechatronic is in the unit and see if indeed, things are heating up. But it might not be as easy to see that like when we do it with a transmission pan versus, looking at the transmission fluid temperature sensor on the typical automatic transmission. This mechatronic assembly, unfortunately, as you see where it's located, the sensor is kind of facing towards the gear train. So it might represent that the actual mechatronic itself is heating up excessively. And normally, if you do run into a situation like this, you do want to check the level or the amount of fluid that is in the mechatronic sump. And of course, you'd have to drain that oil out and actually measure how much oil is in there and then refill it to the 1 liter specification that was presented earlier in this presentation. Now, looking at the gearbox sensor, the gearbox pressure sensor, basically this is going to allow the computer to monitor how much pressure is being built up into the accumulator. So we have oil, again, a limited amount of oil, so we want to keep pressure available at all times for the solenoids to actuate the clutches and to move the shift forks. Not a whole lot of oil is required here. So again, it's not really volume, it's more so pressure. And they're trying to keep this pressure up to a certain level. So if we drop to about 580 psi, then we're going to turn the pressure on. We're going to turn the pump on to generate pressure to get up to about 870 psi. So we got a high pressure situation here pretty much all the time, and we're operating in that range. And there's no way to check this pressure, by the way, so we don't have a pressure tap that we can monitor this. So if we do have any leaks, any issues, any concerns with any of the actuators not sealing properly, it could cause a full run of the pump, the electric pump, because we have an electric pump in there that's actually supplying the motor, driving the motor to actually generate the pressure. So with that in mind, we do want to make sure that our system is operating correctly and the sump level is correct. That's the very important in this unit, since we only have 1 liter of oil to deal with, but there's not a lot of areas where it's going to go. So again, very important to keep that level in mind. Now again, that pressure feedback is going to be very important as far as the runtime of the pump. Here we have the actuators, the shift fork actuators. We show you the locations and the positions. Now, as far as making sure that we know what actuator could be causing problems, we give you the letter number designations for each shift fork actuator as shown in this information. Now, as far as the solenoids are concerned, the solenoids cannot be changed individually, but they can be changed in groups. So as we see here, we have gear train half 1, gear train half 2 solenoid assemblies. Basically, they are available and they are able to be serviced accordingly should you run into any issues. So if one solenoid in one group fails, then you need to actually order the whole set. Now, as far as removing the mechatronic assembly, as I stated before, the mechatronic assembly does have the actuator rods that actually contact the shift forks. So the shift forks are going to actually be visible here as shown in the circled area in the center picture. And we have to make sure that the transmission is shifted into park and that we have to get a special tool to lift the shift forks off of the actuator rods. Now, even with the actuator rods at rest, we're going to have a relative pressure from the shift forks on those rods. So there's not going to be like a free play. So you have to actually kind of pry them up. And there's a special tool that is available either aftermarket or from Volkswagen that you can utilize as shown here. And basically by actually putting that tool in as shown, it'll allow you to simultaneously lift both shift rods and get those out of the way so that you can remove the mechatronic assembly. Failure to do so will cause the mechatronic to hang up and you won't be able to get it off because of these rods still resting on the shift forks. So once we're able to get the shift rods or the shift forks free of the mechatronic assembly, there could be a situation where even if we're in park position, we might not have the ability to remove this mechatronic assembly, because basically we have to command the transmission to neutral internally. So remember, when we put it into park, basically we are actually shifting the reverse slider so that the park mechanism will catch. However, what we need is all of the shift rails in a neutral position. So we can actually command that by a scan tool, and if your scan tool isn't able to perform that function, we can also do it manually. So if we have to do it manually, so in other words, if we get to the point where we're not able to get the mechatronic assembly off, even if we try to command it, command the gearbox into neutral position, then we can actually remove this side cover where the actuator rod is. So we're going to remove this lever and we're going to remove the cover, and just inside we can actually see the mechanism where we can actually move the basically the slider or the fork over enough so that we can go to a neutral position so that the mechatronic assembly can be released, because it will catch and it will hang up unless all the actuators are in the neutral position. So just to keep that in mind, usually the park assembly is the park slider is the one that can hang up, and usually does hang up most of the time, especially if we're unable to command the mechatronic. Say if the mechatronic even failed and we can't communicate with it, we might go to neutral for all the other shift forks, but we'd if we're in park, then basically we would have to manually operate that slider through the window of opportunity that we have by accessing that cover. Now, looking at the mechatronic assembly, we want to take great care in handling this. Indicated are the bolts that you need to remove the mechatronic assembly from the transmission. Again, this mechatronic assembly is going to be facing the radiator of the vehicle that you're working on. It's transversely mounted, and you'll be able to release that by actually taking out the bolts indicated. Do not take out any more bolts than that. The cover that's on there is going to actually be like a protection. If you look at the bulged area, that's where the accumulator, the high pressure accumulator, is located. So that area is, again, it could be distorted because the accumulator could have failed, and you will see, any damage or anything happening right there. It might be obvious or it might not be obvious at all, but that's sort of like a blast cover, if you will, so that if there is anything that happens with that, you will be protected as long as that cover stays in place. So be aware of that. Be very aware of that. Do not remove all the bolts when removing this mechatronic assembly. Now, closer look at that, and we see the warning sign a little bit better here, where you want to make sure that if you're servicing this and there is a question, there's a problem. What we want you to do actually is to drill a hole through the cover into the accumulator housing. So it doesn't take a lot to to drill it. Basically, you're going to be drilling into a gas charged canister. We'll show you a little bit more detail as far as what that accumulator looks like. But you're going to be drilling into a gas charged canister, so you're going to be releasing an inert gas. It's going to be like nitrogen that's going to be back on the back side of that, and the fluid pressure would be on the opposite side of that. So again, the gas charge is going to remain, and that's the concern that you would have as far as the pressure that can actually be released when you release that cover if there is damage done to the accumulator portion of this. Now, when you're installing one of these new Mechatronic assemblies, we want to make sure that we have all of the shift rod actuators in position correctly. So as you see here, each one of those shift rods should measure about 25 millimeters as far as the surface, from the surface to the end of the actuator. So each one would be positioned accordingly. If you get a new Mechatronic assembly, handling with care, they do come pre-filled. Again, it's going to be 1 liter of oil. If it looks like the oil spilled out, you can always drain it out and replace it again. Make sure that you do have 1 liter of fluid in the Mechatronic assembly. Here we show you all the park rails, all the shift rails in the neutral position, and this is what needs to happen in order to get that Mechatronic in and out correctly. So again, that's what good looks like when everything is ready for you to install a new Mechatronic. Here we give you the Mechatronic pin connector pin out. Again, it's not a lot happening here since we have a TCM inside. A lot of this is CAN bus communication. But of course, we got power and ground that we have to be concerned with. We also have keep alive battery power that we want to be aware of. Again, concerns with that can also cause concerns with neutralizing or commanded neutral or failure management that can arise from compromised power and or ground. Here we show you the shift lever sensor. Again, we give you the letter number designation for this, and this is where it's located. And again, it's very critical information that we give you these numbers, these part sensor numbers and locations, because a lot of times you will see this on your scan tools, whatever scan device you're using, and it will give you the OEM reference. And this is so that you can indicate exactly where those components are located. Also included in this selector lever position sensor is going to be the shift lock solenoid. Shift lock solenoid is referred to as N110 as indicated. So anytime we have to replace either one, either the sensor or the shift lock solenoid, it's going to require you to actually replace the whole shifter lever assembly as shown in the picture. Now the oil pump and the motor, again, this is going to be in the Mechatronic assembly itself. So we show you the motor. It's an electric DC brushless motor that's going to be driving a gear type pump. This is a high pressure pump. It's a lot like a power steering pump. So we're not moving a lot of volume, but we're creating a whole lot of pressure. So this pump does not run all the time. Again, it's going to be on demand, controlled by the TCM or by the Mechatronic computer. And it's going to give us a maximum of 870 psi when we're fully loaded. As far as the draw on the motor itself, it's an amp draw. It's going to have a peak of 20 amps, but it's normally going to operate between 8 and 12 amps under normal conditions. So for blowing fuses or anything like that, that could indicate that we have an issue with this pump. If there's an issue with the pressure sensor, the one that controls the on-off cycling of this pump, then we can have a full-time run of this motor, in which case we will go up to the maximum pressure of 1,000 psi or 70 bar, just as a fail-safe to make sure that we have enough pressure to operate this unit. So in cases of that, that's where we have issues and concerns that can arise from mechatronic failures due to stress from running at high pressures for extended periods of time. Here we show you the pressure accumulator itself. Now again, this is with the cover off. Now if there's any issues or any concerns that there might be issues with this pressure accumulator, it's best to drill a hole into this cover before we take the cover off. Again, that protective cover is going to act as a blast containment, if you will, should this assembly just fail completely. Because on the opposite side of this pressure accumulator, facing towards the unit, facing towards the valve body, is a snap ring and a piston. And what happens is the oil that's pressurized from the motor and the pump goes into the backside of that accumulator and actually fills that accumulation relative to the pressure that's the gas pressure that's on the opposite side of that accumulator. So we're pushing oil in there, so basically we're working against that air pressure that's already charged in that container, and then that's how we store the oil pressure. And then whenever we need to fire a solenoid, that accumulator is going to be able to release that oil instantly and allow for the pressure to go to the circuits as designated based on solenoid firing. So again, it's a very critical point of operation of this mechatronic assembly, and virtually the nerve center of this unit. So just to keep that in mind. The rail operation of the mechatronics is another area of concern. Basically, we have to know, we have to have some kind of a feedback to let us know if the shift rails moved and, how far they moved, if they didn't move. So we do have a feedback mechanism where the mechatronic has a sensor that's going to be able to look at a magnet relative that's attached to the shift rail as shown. And as that magnet moves relative to that sensor, basically it can tell if it's moving in the correct direction for the correct gear. So again, it's going to be a directional magnet with a north-south pole. So the sensor is going to be a Hall effect type sensor that we're going to pick up that movement and it's going to be used as a feedback for the computer to determine if the shift indeed occurred. Of course, if the magnet falls off of the rail or if there's contamination on that magnet, it can cause for an improper reading. It can cause for no shift commanded, all kinds of concerns. Codes can arise from that magnet or the sensor failing and not reading correctly. Now, basically, as far as the shift rails are concerned, we give you all of the information on what sensor, what valve is going to control which shift rail. Again, it's very important to realize if we do have a solenoid failure, we are going to have gears that are going to be inhibited. Usually it's going to be 4 gears that are going to be inhibited. If we have a solenoid failure, a shift rail actuating solenoid failure. So just to keep that in mind, and this is a designation of what kind of failure to expect based on the solenoid failure. Now, as far as this unit's concerned, we do have a basic settings procedure or clutch relearn procedure that we have to follow once we service this unit. So in order to do this, we have to make sure that our computer is able to communicate on that level. Again, this is going to be Volkswagen, Audi type logic more than anything. The factory OEM tool is going to be called the VAS 6150E. That's the OEM factory scan tool. However, there's a lot of aftermarket tools that are available that can perform these functions. So just keep that in mind. You more than likely don't have to go to the dealership, but you do want to verify that whatever scan tool you choose to use, that you are able to perform these functions, because it's required after you service the clutch, after you service the TCM. So with that in mind, we want to make sure there's no fault code stored. We want to make sure that our transmission temperature sensor, now that's going to be the G510 sensor, so we want to look at our scan tool and indicate that we are between 30 and 60 degrees centigrade to make sure that we are going to be able to perform this procedure. If we're not in that range, the procedure will not initialize. Then we're going to select park and the engine off, ignition on, engine off, and then procedure would initiate with the other items, parking brake applied, as well as the we're going to hold the service brake as well, and we're not going to touch the gas pedal. Then we can go into the system and actually go through the system steps as initialized by the computer. So also we give you a little bit more insight on this too, because sometimes it's hard to tell with some applications, especially Volkswagen, Audi. Now, as you're going through this procedure, you're going to see the measuring blocks change as indicated. Now, if we have our data at 22, well, as shown in 254.00, basically that should give us a completed process. So again, if we don't come up with that 254.00 in our measuring blocks as indicated, then we might have to wait a little bit further. So again, we want to make sure that the system goes through the test completely. And again, you're gonna hear clicking noises, all kinds of things that are going to be taking place. But it's going to take a while to get to the end of that process and the procedure. And just give the scan tool time, give the vehicle time, and then usually, after about, it's usually going to be about 5-6 minutes, and then it will be completed. And then once those measuring blocks stabilize, again, you want to look at that final number, then you're going to be able to confirm, with a test drive after we're completed. If it doesn't reset accordingly, according to the numbers here, then we're going to have to start the procedure over again. Then, after we go through the scan-driven procedure, we're going to have to go for what is known as a defined test drive. The defined test drive, basically, we want to, again, make sure that the transmission is at the proper temperature. And basically, we're going to go through the drive procedure as indicated, and it's going to allow the computer to actually see what's happening as far as the shift transitions between the K1, K2 clutches. And it's going to be timing the torque transfer as well as the engine RPM. So it's very important that we follow this procedure step by step, because if we don't do this and we deliver the vehicle to the customer, there can be tie-ups, there can be flare shifts, all kinds of things can occur because that learning process didn't take place. Even though there is going to be an adaptive learn beyond that that's going to compensate for clutch wear, if it's not set up properly, it can cause premature failure. So again, it's necessary for us to do this defined test drive as indicated in this material, and that will put the vehicle into service in the fashion that it's supposed to. And then the driver, as it wears, it'll actually adjust from there. Software updates are very prevalent in this unit, so always make sure that, when you get into one of these units, we want to make sure that we have the latest and greatest software for our mechatronic assembly, as well as any powertrain management software. Again, the two work hand in hand. Torque management is very interactive in this type of system, so that if the engine is not running correctly, or if we don't have the proper software updated on the engine side, we can have some issues that can occur on the transmission side. Now, as far as servicing this clutch assembly, you are going to need special tools. Again, Luke is the OEM manufacturer. Luke does have a very excellent toolkit that goes along with their rep kit. So with that in mind, we do want to be aware that if we're getting into these units, we are going to have to get some tools to work on this accordingly, because we do have to adjust the clearance on the clutch. Okay, the clutches have to be adjusted with shims, and all of the instructions come with the kits. Now, Luke isn't the only one that makes this kit, of course. However, again, being the OEM, it's highly recommended to go with this, simply because they're going to have everything in the kit that you need relative to your make and model, and they're going to have the instructions as far as setup and clearance on those clutches. Failure to set the clutch clearances and use the proper shims is going to cause premature failure, or even a neutraling situation with no engagement or restricted gear use. Now, as far as the clutches are concerned, we got 2 generations of clutch kits. Again, we want to utilize our VIN number to verify that we are accessing the correct clutch parts so that we can get what we need for our application the first time out. Model year is around July 2011. Basically, that's where our Generation 1, Generation 2 split occurs. And basically, the parts and pieces are going to differ from there. Now, looking at Generation 2 versus Generation 1, first of all, if we're just glancing at the clutch itself, so if we get the components out of the vehicle, get them on the ground, we can look at the clutch assembly. Notice with the clutch assembly with the Generation 1 is shown here. We have like a ring surface there around the inner diameter. Basically, that's going to indicate a Generation 1 clutch assembly. So that's one real good identifier. Now, Generation 2 is going to be a little bit different. When we notice we lose that ring. Also, another thing we lose is it's going to be another thing that's different is the actual shims. We're going to have conical shims that are going to be used on the K2 clutch fork adjustment. So again, that's going to be something that we're going to be aware of as we're disassembling this unit, and that will let us know if we have the correct clutch kit just by matching those parts up in general. Now, I was referring to the accumulator housing area. Now, basically this accumulator housing itself is made out of a steel material, but it screws into an aluminum housing. And basically, if you got steel and aluminum, you know which is weaker, aluminum. One of the concerns with this unit, a very common concern, is for the accumulator pressure to leak out through the aluminum casting side of the valve body, creating damage as shown in this picture. Sometimes you can have a diagnostic trouble code of P17BF. Also, you can have very little movement or just slipping, poor clutch, like flares on shifts. So the complaints can vary depending on the severity of what's happening there. But a lot of times, if we start to leak there, then that area is weakened. That accumulator becomes unstable, because basically what we're trying to do is we're trying to force pressure into there, and something usually either gives on the aluminum side where we see, or the actual accumulator can actually become distorted and actually cause the piston, the accumulator piston that actually that the oil actually works against, that can actually become dislodged. And there's a snap ring that is actually retaining an accumulator piston in there. And if that lets loose, then basically that's when the accumulator becomes very dangerous to handle, because the pressure can still remain there if it's still able to stay screwed in. But time as you release the pressure off the cover, then that's where the two pieces can go their way, and they often do. And again, that's going to be something that you don't want to, take a risk with. That's why we're saying you do want to drill through this if there is an issue, a drivability concern with a no move or very little move, slipping, and the mechatronic assembly is suspected. Then you do want to drill through that cover as well as into that accumulator, and then you'll hear the gas come out. The pressure will release. Once the pressure releases, then you can handle it. Then you can take off you can unbolt the cover off of the mechatronic assembly and access all these components in here. And again, everything is available in the aftermarket to service this transmission. So just to keep that in mind, even the castings that blow up like this, they are serviceable in the aftermarket as well as from the OEM. Now, some of the concerns that we have with these units are gearbox noises. Of course, we mentioned we have concerns with bearing failure. Of course, that's going to generate noise. But we also have a concern with like metallics knocking sounds, rattling sounds coming from the gearbox assembly. Between first and fourth gears, usually when there's a higher torque differential, lower RPM. Basically, this can be a situation where with the throttle released, we can have an issue with the TCM actually monitoring what gear needs to occur next. So again, with the transition, depending on what kind of driver you are, if you're a nervous foot driver, it will be more pronounced, of course. But this will be something where it can be corrected with the latest software. Again, this would be more of a shift busyness situation where the computer is trying to figure out, okay, what do you really want to do? And it's oversensitive. So basically this reduces the sensitivity, and it allows for a more stable, shifting select pattern, even if you're kind of uneasy on throttles. Clutch issues. This is going to be a situation where we can have some codes, relative codes as shown here in the information. This can be relative to an issue with our power supply to the mechatronic assembly. Now, in some applications, they have the wrong fuse that's actually in the mechatronic power supply. It should be a 30 amp fuse. Now, this would be something that you do want to verify with your fuse location and manufacturer specification. So again, if this fuse blows frequently, and again, it might be relative to the pressure, the pump motor actually cycling on and off. And if that happens to be a simultaneous situation, you do want to, of course, verify your current draw by using a breaker and an amp clamp in that application, because that could indicate, a failing pump motor, or we could have a fuse that is of the wrong rating in that location. Another concern is clutch issues as far as engagement and disengagement. After a clutch service where we can actually have neutralizing or flaring or even binding. This would be a situation that we would experience after changing a clutch. And that would be a matter of us not setting the clutch up correctly. Using the wrong shim will cause our shift overlap to be compromised, and it will give us a shift complaint. Basically, it can go to severe as neutralizing. Again, with that in mind, it's very critical to follow instructions on the clutch kit that you use to adjust the end float of the clutch properly. Now, another concern is rattling. Rattling noises basically is a very common situation, especially with the diesel applications. So just to keep in mind, we're looking here at the teeth of the dual mass flywheel, and this is the top picture is what good looks like, and the bottom picture is what bad looks like. Pretty much what happens is with time, we can actually have the dampening mechanisms inside the dual mass flywheel actually collapsing and failing and allowing too much movement. And if it allows too much movement, basically those teeth, those retainers that you see there, they get struck, and once they are struck enough times, it's going to be a matter of time before it fails. So with that in mind, it's very important. Now, it's very important to realize that this damage can occur. Now, as far as this being a repeat failure, which is highly possible, we could have an engine that does not have a proper engine balance, cylinder firing balance. So with that in mind, if we have a diesel engine especially, that's kind of hard to determine just by driving it down the road, unless it's very excessive. So you might have to have the engine analyzed if we have a repeat failure, similar to what we see on the bottom here, and we might have to have engine work done to get the cylinder balance correct so that we don't take out these dual mass flywheels repeatedly. Another area of concern is rattling noises. This can be caused by damage to the flywheel dual mass flywheel teeth here, as shown. And again, if these teeth get damaged, they're going to allow for too much movement, and that would give us that free play or rattling noise that we hear. Shudder, judder, it's going to be a situation where we can have a concern where certain models of 2008 units, 2007, 2008 model year units can actually have concerns with the mechatronic failing. So if our mechatronic is falling within the serial numbers indicated, we definitely want to make sure that we replace it and then retest. Otherwise, we can have some clutch related concerns directly associated with this shudder or judder situation. Now, another concern can be a shudder, judder, and no drive when changing ranges. This can be caused relative to some concerns with the TCM and ECM programming, where the applications need to be updated. So again, it's going to be a situation where we can have either engine stall, cold, shudder, judder when stationary while using the brakes, clutch protection mode, or no drive when changing ranges from reverse to drive. Selector display may flash. So again, if we get any of those indications, then we definitely want to check for the latest programming for both the TCM and the ECM. Shudder and judder between engine speeds 25 to 3,000 RPM. It's going to be a situation where we can have a wastegate and a turbocharged type applications where the wastegate can be sticking. In the case where this is suspected, then we can actually check the wastegate manually by using a vacuum source, a variable vacuum source, and actually observing the operation of the wastegate from full open to full closed. So again, that's something that we can check and verify so that we are moving in the right direction for diagnosis. Diagnostic trouble codes 2723, 2732, P0702. This can be a situation where any of the codes can be set relative to each other. We can have a problem with our software. Basically, these are voltage codes as monitor, circuit feedback type situations. Of course, if we check the circuits, all we have to check is power and ground. Before we condemn a mechatronic, we definitely want to make sure that we have the latest updated software, because this could be improper reporting of these codes by the mechatronic assembly. Will not change gear, shudder or judder. It's going to be a situation where codes can be possible. Again, in play or free play, if it's too small, it is going to give us this complaint and we can have a situation as the unit wears. This is going to give some concerns with the application of the clutch relative to the ability of the mechatronic to adjust for the wear. We can just be outside of the parameters and we'll have this shudder or judder. So this might indicate that we need to replace the clutch assembly in this case. Gear display flashes, diagnostic trouble code set. Again, we give you a series of diagnostic trouble codes that are listed here, specifically the P0841, the 02115X or 02113. Basically, with those codes present, the combination of those, basically we are definitely going to indicate we need to update the computer calibration. Then we get to the Tiguan applications. There's a lot of concerns that are arising from these possible concerns. Any combination where the vehicle won't start, parking brake related issues, check engine light on, incorrect display in the driving mode selected, poor engine performance, gear shift will not move from park, gear change is incorrect, glow plug light flashes. All of these can be related to concerns with wiring, the connection, corrosion in the connections in the gearbox switch, the gearbox malfunction switch, fog lights, and headlight cleaning pumps. We want to check those connectors for corrosion in those areas for applications 2010, model year 2010 and earlier. So again, this is going to be a known problem with water intrusion and corrosion in the indicated areas in this material. That will conclude our information on the 0AM transmission.